As you can see, it is a 3 hours paper, 150 marks. So we're going to focus on the following. We shall be looking at climatology, geomorphology, and settlement, and as well GIS, which includes also map work skills and techniques. All right, so those are the instructions as usual. Then, so we go to our first questions under climate and weather, there is geomorphology, settlement, geography. So question 1, we are looking at climate and weather. Climate and weather. So they say, refer to the diagram below which depicts a valley in the southern hemisphere. Choose a term from column B that matches the description in column A. Write only letter X or Y next to the question number in the answer book. For example, 1.1.6, which is X. So that is another instruction that you must also look at very carefully, whereby you just have to indicate the number and the given letter as they've indicated to you here. This is the letter. All right. So that is the diagram which does show or depicts a valley in the southern hemisphere. Something maybe to look at. They're showing us here is sinking cooler air traps warmer air. Then here they're showing warm air displaced upwards. Then here they're showing 10 degrees Celsius, that is at point D. Looking at point A, there is an arrow pointing to the valley bottom. Also, on the other side, they say cold air sinks down the valley slope. Here they're showing there's frost-sensitive crops, frost-resistant crops, south-facing slope, and on the other side, the north-facing slope. All right. Therefore, let's try to analyze and look at the various questions to see if we could get out, understand. Okay, first try to create this. All right. Column A, question 1.1.1, they say the area marked D is the, let's go check area marked D. So this is our area marked D. This is our area marked D here, this area. So it is referring to the whole of this section. All of this section is area D. Now, is that a thermal belt or layer of fog? And our answer is supposed to be X, which is supposed to be a thermal belt. Thermal belt for the first question. So we take X because, why a thermal belt? Because we know at this point, temperatures increases with height, or it is a warmer area. And that is, if it does happen in the valley, that would be the thermal belt. All right, number 1.1.2, they say the slope is cooler in this valley. Is it the south-facing slope or the north-facing slope? For our answer, because the instruction here showed us that this valley is situated in the southern hemisphere. Now, that is a concept you need to take into consideration to understand this question 1.1.2. Let's try to use this to see if we could understand this one nicely. What I'm going to do, I'll try to draw, I'll try to draw a globe. It's a sketch, sorry. Then I indicate this is our major line of latitude, 0 degrees. Then we have the northern hemisphere, and we have the southern hemisphere. So what I do, I could indicate two slopes there. This is the north-facing slope and the south-facing slope. This is our slope here, which has two sides, one facing the north and one facing the south. We as well have the same in the southern hemisphere. This is our slope. It has a north-facing slope and a south-facing slope. Then we have our insolation or the sun, this other side. And the sun, and see the rays of the sun that are hitting the south-facing slope in the northern hemisphere. So it means that if we look in the northern hemisphere, the south-facing slope is going to be much more warmer, because it is receiving direct heat from the sun. Whereas the north-facing side is going to be a bit cooler due to the angle of the heat from the sun. If you look at the north facing in the southern hemisphere, it as well going to be warmer because it also receives direct heat from the sun. So meaning in the southern hemisphere, the north facing slopes are warmer. And in the northern hemisphere, then the south facing slopes are warmer. So if you go back to our question, which says the slope is cooler in this valley. But now don't forget, this valley is situated in the southern hemisphere, right? According to our illustration here, now we are situated in the southern hemisphere, meaning in the southern hemisphere, the south-facing slopes are cooler, yet the north-facing slopes are warmer. So that is why for our answer for 1.1.2, it means the south-facing slopes are cooler in the southern hemisphere. So it means our answer will be Y. Right. 1.1.3, the wind blowing at E generally occurs during, this is E here. This is our E. You can see the wind is blowing down the valley. See, so they say it occurs during which time? And of course, that has to be during the night time. So our answer will be why. Why do we say night time? Because we know that during the night, the land gives off what we refer to as terrestrial radiation. Terrestrial radiation. So due to terrestrial radiation, the land loses the heat and it becomes cold. So this point is going to be cooler. Then what happens to the air around this point? So the air as well becomes cold. And when the air becomes cold, we know it will be more dense, or it will be much more heavier. Therefore, it will start to blow down slope or downwards to the valley bottom. So it means that terrestrial radiation is more during the night time. So whenever we have terrestrial radiation, it means the air becomes cold and to start to subside or to descend. So that is why we say for our question 1.1.3, the wind at E, it will occur during the night time. 1.1.4, the temperature at D is higher because of, let us first look at point D. You can see this is our point D here. They're saying the temperature at this particular point are higher, and this is due to, they're saying, because of the temperature inversion. So for that case, our answer will be X, which is temperature inversion. What is an inversion? It refers to, we could define inversion as where temperatures increases with increase in height. So temperatures temperature increases with height. With height. So as you can see, that's why the temperature at D is higher as a result of the temperature inversion. All right. 1.1.5, it says frost pockets develop on the dash of the valley, which is going to be the floor. So our answer will be X, because we know that whenever air subsides to the valley bottom, it does settles at this point. Where it settles now, it forms what we call a frost pocket. A frost pocket, a region where cold air settles in the valley. So that's why for our answer for 1.1.5, it will be the floor. Frost pockets develop on the floor of the valley. All right, so that is for question 1.1. All right, let us proceed to the next question, which is 1.2. They're saying, refer to the isotherms below of an urban area showing the pattern of temperature during calm atmospheric conditions. Choose the correct letter, A or B, from figure 1.2 to make the statement true. So for this case, the thing that we are looking at here, there's this terminology, which is the isotherm, right? We have the urban area and as well the pattern of temperature. So these are the major concepts that we need to identify in this statement, right? We need to understand what is an isotherm. So we could define it as lines joining areas of same temperature, right? So isotherms are lines joining areas of same temperatures. As you can see, now these are different isotherms. Someone may think they are isobars or control lines. No, these lines do change depending on what they are indicating. If we are dealing with temperature, we refer to them as isotherms, right? So you can see, for example, we have this isotherm here, and you can see it is being numbered 5. This other isotherm being numbered 6, another one being numbered 7, 8, 9, 10, etc. All right. So as well, there is a scale to indicate distance in kilometers. They're as well showing us there's also a river, which is being referred to as thumbs, rivers, up country. This could as well refer to as the urban fringes here, the up countries here. All right. So this is our river going through up to this other point. All right. Looking at the questions, 1.2.1, it says air temperature is highest at A or B. Remember, you choose one. You either go with A or you go with B. But for our case, we need to make the statement. They said, choose the correct letter, A or B, to make the statement true. All right. So air temperature at A. So they say air temperature is highest at A or B. Now, we know that point B, this is the upcountry, or the same as a rural-urban fringe. Rural-urban fringe. And we know this area, they always experience lower or low temperatures. And at this point, which is at the center, this is the urban area. All right. So they are saying temperature is highest at point A, because point A, that is our urban area. And we know that in the urban areas, due to tall buildings, artificial sources of heat, concrete, glass, so many factors, they contribute to the temperatures being higher in the urban areas as compared to the open country or the rural urban fringes. So that's why our option is going to be A. For 1.2.2, they said area A or B has more artificial surfaces. And when they say artificial surfaces, they are referring to materials or things that are man-made, which contribute to temperatures rising. Like we mentioned, there are a lot of tar roads, concrete, lights, bricks, glass, metals. All these, they contribute to temperatures rising. So when they say A or B, which one has more artificial surfaces? So definitely it has to be the point A, which is the urban area, because if we do compare the urban area and the urban fringes, yes, even the urban fringes or in the open country, they are artificial surfaces, but they are less as compared to the urban areas. That is why we are going to consider point A having more artificial surfaces. All right, 1.2.3. The city center is at A or B. How do we tell? Now, we go back to our instruction here where they say, refer to the isotherm map below of an urban area showing the pattern of temperature. Right. Now, this is an urban area. However, we know that urban areas always have higher temperatures as compared to the rural areas. So, I mean, B is our rural area or the urban fringes, and A is an urban area. So, meaning urban areas always are going to have temperatures will be a bit higher, and rural areas temperatures are going to be low. All right. So having that concept, so it makes us understand that the city center will be at point A, because even the isotherms themselves, look at the open country, it is 5, 6, 7. So it means that as we move from the open country, moving towards point A, the temperatures are increasing from 5, 6, 7, 8, 9, 10. You can see. So there is increase in temperatures. All right. So which means that the city center will be at point A. All right. 1.2.4, cloudy cover is higher or more at point A or point B. So as well, when they say cloudy cover, they are referring to the rate of condensation, which is going to be at point A, because we know that at point A, due to many factors, so there will be a lot of convection currents, which is going to result into more condensation taking place, giving us dense clouds or overcast clouds. Because as well, we can mention about the hygroscopic nuclei in the cities or in urban areas, which also contribute to more cloudy cover conditions. So that is why we say it will be more clouds in urban areas as compared to the open area, open country, or the rural urban fringes. 1.2.5, river thermals has a cooling effect on A or B. Now, remember we said that at point A, so our point A here, temperatures are already high. So temperatures are already high at point A, and temperatures are low at point B, you see. So it means that if there is a river flowing through point A, which experiences higher temperatures, it means the river this river will try to cool down the urban areas so that it is not very hot. So that is why we say 1.2.5, the river will have a cooling effect on point A. All right. So far that those are our question 1.1 and 1.2. Let us proceed to the next question, which says 1.3. Refer to the infographic below showing the information on tropical cyclone. Now, some learners don't understand when they say infographic. So this is information, right? So it is referring to information which will be in the form of pie charts, diagrams, extracts, pictures, like as they show you here. So this is all information in a graphic format. All right, so it means Reunion Island as well. Then look at the extract. They say Cyclone Freddy. All right, just to go through this extract, it says one of the longest lasting weather systems in the southern hemisphere, ex-tropical cyclone Freddy, is expected to bring heavy rain and a risk of flooding to Madagascar's western and southern parts from tomorrow, bracket Friday evening. They say Friday weakened from an intense Category 4 equivalent to a Category 3 cyclone ahead of landfall on the easterly Malagasy coast near the town of Manjari during the evening of 21st February, with sustained wind speeds of 150 km per hour. All eyes are once again on Freddy, currently classified as tropical depression, as the eastern is expected to re-intensify in the Mozambique channel. All right, so that is our infograph. Therefore, let us try to look at the following questions. Okay, so 1.3.1, they say, with reference to the infographic, identify the general direction in which Cyclone Freddy is moving. Okay, because they say with reference to the infographic. All right, let's go back and we look at our infograph, or look at the graph. Okay, so identify they say identify the general direction. So learners, we should not confuse direction with rotation. For this case, they're not referring to the rotation. Instead, they are referring to the general direction in which the cyclone is moving. So this word moving, it means someone is moving from one point to another point, but it's not spiraling, right? So if we check on our infograph here, for example, this is about the cyclone. You can see 20th February, the cyclone was at Reunion Island there. Then it moved 22 of February, you can see. Again, it moved 24 February, and again to move to 27 February. What does that indicate to you? If you draw our compass here, for example, this is our compass. This is the east, this is the west. So if I could put, let's say, this is 20 Feb, and I say this is 22 Feb, and I say this is 24 Feb. So you can see the second was moving like this. You see? So it means it is moving from the eastern direction going to the western direction. All right. So as you can see it here, it is moving from this direction going this side by the mere factor of the date given on the graph. 20 Feb, 22 Feb, 24, 27. Therefore, for this, our answer is going to be, it is moving, could say, moving from east to west. Or sometimes you can as well say moving to the westerly moving to the westerly direction. All right. Then number 2, 1.3.2, they say account for the movement mentioned in question 1.3.1. Why is it moving in that direction? Why is it moving from the east going to the west? Then you're going to say because of the influence, or could you say being driven by easterly winds. Driven by easterly winds. I believe all of us understand what are easterly winds, because we know that winds are named from the direction where they are coming from. For example, if we go back to our compass that I drew earlier, for example, first move this. Okay. Bring it down here first to understand more about these winds. So we know if I do my compass here like this is the east. So if you have winds that are coming from the east, going this other direction, so these winds are going to be referred to as the easterly winds. So it will be the easterly winds. Then, all right. So we are going to refer to this as the easterly winds because they are coming from the eastern directions. So winds are named from where they come from, where they originate. So if we have another wind, for example, because this is the western side, if you have this wind, for example, coming from the west, going to the east, now we're going to refer to this as a westerly wind because of where it is coming from. So that is how winds are named, from where they originate from. All right. So let us proceed to our next question, which says, give evidence from the infographic that Cyclone Freddy was accompanied by hurricane force winds. Remember, this evidence, what the evidence, it refers to proof. Need to give proof from where? From the infographic that Freddy was being accompanied by hurricane force winds. If you look at the infographic, hurricane force, we know these are very strong winds. So we can see one of the evidence. Look at the trees. Look at the trees, the shape of the trees. You see, because trees are not supposed to be. That's not their nature to be in that position. It means they are being blown by these strong winds. And as well, if you can look keenly here, these are boats. They look upside down, which as well indicate. If I try to zoom in, for you to understand or to be able to see clearly, you can see that these are boats, but they look upside down. And that's not the case, right? So this is evidence that something was happening there related to Cyclone Freddy. So if you go back to our questions, let's give evidence from the infograph. Give evidence from the infograph that Freddy was accompanied by hurricane force winds. So we could mention about trees being blown, trees blown by hurricane winds, trees blown by hurricane winds. That's one point. Could as well say boats have been swept on shore. Swept on shore. Or we could as well say boats look upside down. Boats look upside down, which is not the case. So those are the three evidences we could give to prove that Cyclone Freddy was being accompanied by hurricane force winds. All right. If we continue to question 1.3.4, they say, according to the infographic, the system is re-intensifying, and in bracket they're saying getting stronger in the Mozambique channel. Explain why the weather system will re-intensify in the Mozambique channel. So you can see this, they're saying, or they made it easier for us to, where they're saying the word re-intensify means getting stronger, right? To get stronger in the Mozambique channel, all right. All right, so re-intensifying, the same as getting stronger. But they are referring to Mozambique channel. Let us try to see which one is Mozambique channel. Let's go back to our blank page here. Red line. If I can draw the sketch map of Southern Africa here. Okay. Somewhere here we have Madagascar. Now this part here, this is the Mozambique channel here. Of course, we have Mozambique as a country somewhere here. And this is the Indian Ocean, the South Indian Ocean here. So this is the Mozambique channel, this corridor, referred to as the Mozambique channel. But remember, cyclones, for example, they could, or they normally develop from this other side, and they move westwards in this direction, like we've seen before. They move from westwards, coming from the east, moving towards the west. Now, sometimes when they reach Madagascar, they could dissipate. If they happen to cross over Madagascar, then they could regain their energy over the Mozambique channel. So this is where the question I want us to focus on, which says, according to the infographic, the system is getting stronger in the Mozambique channel. Explain why the system will re-intensify in the Mozambique channel. We must give reasons what will make the cyclone to become stronger in the Mozambique channel. That's why to give some answers here. One could say the channel, not the TV channel, but that corridor. The Mozambique channel has warm conditions, which favors cyclone 2 to regain its energy, such as latent heat. Okay, we could as well say the channel has higher temperatures, which results into high condensation results into high condensation, high condensation, and latent heat. Okay. Remember, all these conditions will make the cyclone to regain its energy. Okay. We could as well say the channel 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 has high temperatures. Channel has high temperatures. High temperatures, which results into intense low pressure. Intense low pressure. Okay, so those are some of the responses why the Mozambique channel will be or will enable the cyclone to regain its energy. I could as well give another option, and we say there will be less friction. There will be less friction, less friction, less friction, enabling the cyclone to strengthen, to strengthen, strengthen. So those are some of the reasons we could give as to why the channel will enable the cyclone to re-energize or to re-intensify or to become more stronger. All right, so that is for question 1.3.4. So let us proceed to question 1.3.5, which says tropical cyclones can develop very quickly. Therefore, a reliable early warning system is important. Suggest 3 early warning systems. They're saying suggest 3 early warning systems that the government of Mozambique and Madagascar could have introduced to reduce the impact of Cyclone Freddy. Remember, dear learners, when they say early warning systems, they are not referring to strategies to put in place to reduce the impacts. Because some learners for these questions, they might think of things like first aid, evacuation centers, having sandbanks at the coast. Those are not warning systems. All right. So for 1.3.5, let us go back to our blank page and try to suggest those warning systems. This will be for question 1.3.5. So you could say they could use media such as TVs, radios to inform people. Okay. As well, use silence. Silence like something that will make an alarm. Could be, remember when we were in high school, we used to have a siren at school, which is being rung to sound or to make that noise or alarm to alert people or to inform people, either it's break or kind of. So if the government could as well introduce these in areas of intense cyclones. So people will get used that whenever there is a siren, it will mean either to prepare or to move out of danger. So we say use sirens to alert people. Would as well say would use social medias, use social media platforms such as Twitter, Facebook, TikTok, to inform people, because we know nowadays majority of people are on social media. So if we can use it as a systematic strategy to as well inform people. We could as well think of using satellites. Use satellites to monitor cyclones, so as to alert people, among other responses or systems. But remember, the question is asking for three strategies, or sorry, three systems that could be introduced to reduce the impact of cyclone flooding. So meaning, if you use TVs, radios to inform people, at least somehow could reduce on the loss of lives. If you use sirens as well to alert people, this could also reduce on the impacts. And as well, if you use social media platforms like Twitter, Facebook, TikTok, because we know most of people are involved in such platforms. Therefore, all right. Let's go to question 1.4, which says, refer to the figure below depicting the formation of line thunderstorms. So as you can see here, this is our figure, a diagram. We have the South Atlantic high pressure cell, this other side. We have the South Indian high pressure cell, this other side. And we know here there is a pressure gradient, because we have a high pressure cell and there must be a low pressure cell, which was not indicated. But because of the air movement, because we know air moves from high pressure going to the low pressure, high pressure going to the low pressure, like that. All right. So as well, you need to know that the air from the South Indian high pressure cell crosses over the Mozambique Channel. We have spoken about the Mozambique Channel here, that this area has warmer conditions or has got higher temperatures. So it means if the air passes over this Mozambique Channel, the air is going to become warm, or it will be warmed up, gaining a lot of moisture. So meaning that this air is a warm air. All right. But this other side, we have the Benguela currents blowing over this other area, so making this region to become a region of cooler conditions. So if air crosses over this point here, so the air becomes cold, or you can as well refer to this as cooler air. It is cold or cooler as a result of the Benguela currents. The Benguela currents. Okay, so for now, that's what we need to learn about that. So they say, name a characteristic of the air at A. Now this is our air at A here. This is our air at A. And we already know that it is a warm A. You see? So we're going to say that the characteristic of the air at A, it is warm, moist air. Warm, moist air. And 1.4.2, they say, name a characteristic of the air at B. This is our air at B here. This is our air at B. Like I mentioned, this air is crossing over cooler conditions. So it means it's going to be a cold, dry air. This is similar. It's like when you put your hand in a deep freezer. It means a deep freezer is an area of cold or low temperatures. So it will make your hand to be as well to become very cold. Reason? Because you're putting it in a region of cold air. But if you put your hand next to a heater, the hand is going to be warm. Why? Because the heater is an object of warm conditions. So therefore, the same applies to air at A. This air at A is crossing over the warm area. Therefore, it will become a warm air. Now, this air is crossing over cooler conditions here. So it will become a cold air. All right. Question 1.4.3, describe how the A and at B contributed to the formation of the line at C. All right, let me first try to make it look more clearer. This, okay. Okay, so the question says, sorry, describe how the air at A and at B contributed to the formation of the line at C. I believe all of us know that line C, this is the moisture front. This is our moisture front. So actually, they're asking how does it develop? But for this case, they're saying describe how the air at A and at B contributed to the formation of the line at C. The line at C is our moisture front. Let's go back to our blank page. Try to give some responses. There's 1.4.3. So we're going to say that the cold southwest winds meet with warm northeast winds over the interior. Over the interior of a low pressure. Okay, let me go back to the diagram to show you this, because we are saying the southwest cold winds. These winds are going to be referred to as southwest. Remember, why are we referring to them as southwest winds? Because of the direction or the pattern of the direction where they are originating. If I put our compass here, for example, this is east, this is west, this is gonna be southwest. So if you look at our pattern here, you can see that these winds are originating in that pattern. That is why we are saying, or we are referring to them as southwest cold winds. And why are they cold? Because we have seen in the previous question that these winds are crossing over the cold Benguela current over this other area. Therefore, they will become cold winds. Then we are saying, of course, this one here is going to be the northeast, because it means the winds are coming in that direction. So we can refer to these winds as the northeast winds. So when you come back to our diagram here, you look at the pattern of this wind. It is coming in that direction. This is why we are going to refer to it as a northeast warm wind. All right. So, and they must have told you that how does air move? And we know that it moves from a high pressure going to the region of a low pressure. So it means this is our interior. Over the interior, we have this low pressure cell. Sometimes we refer to it as a heat low or a thermal low, which means it results into the migration or the movement of air from a high pressure to the low pressure, from high pressure to the low pressure. So you can see we have our southwest cold wind meeting with northeast warm winds over the interior of a low pressure. All right, that was our first option. Then we proceed and we say the southwest cold winds undercuts the warm winds then we proceed and say the warm winds rises. The warm winds rises, forming a boundary referred to as a moisture front. I'll go show this again on the diagram. So, like I mentioned, cold air comes in, warm air comes in. So when they collide at this point, cold air undercuts warm air because it is cold and dense, making the warm air to continue rising. So when warm air continue rising, it will end up now forming a moisture boundary, which we refer to as a moisture front. So that is how we could answer question 1.4.3. All right. Let us proceed to question 1.4.4. The same, which side, east or west of the line at sea, will there be cloud formation? Which side, east or west of the line at sea, will there be cloud formation? All right, let's go back to our diagram here. Let me try to make this look, move this, make it more visible. Okay. Erase on this so that we can see. All right. So the question is asking, or is saying, which side? Okay, question 1.4.4. Once again, it says, which side, east or west of the line at sea, will there be cloud cover? So let's go to line C. This is our line C here. This is our line C here. And like now we know this is the moisture front. But we know it has the eastern side. This is the east, and this is the west. So when it says which side of line C, which side of line C will there be a cloud formation? Okay. So I go back and see. So we said before that warm air and cold air, they meet over this area. So when they meet, this is our cold air coming in, and this is our warm air coming in. When they meet, cold air forces warm air to rise. And you must know this, that what happens when warm air rises? It means it's going to condense. When it condenses, it means there'll be formation of clouds over the eastern side. And yet the western side, for this case, western side, since we do not have air rising, so this side is going to be dry. Yet this side will be wet. It will be wet as a result of the different clouds that are developing over this other side. Therefore, we say the eastern side. This is the eastern side. Let me move this again. So this will be the eastern side, the east side of line C. This will be the west of line. This is our line here, right? So this is the eastern side of line C. This is the western side of line C. So the eastern side will experience more clouds as compared to the western side. So for our case, we're going to say the east side of the line. Okay. 1.4.5, they say in a paragraph of 8 line, discuss the negative impact of line thunderstorm on the environment of the eastern half of South Africa. They're saying negative impacts. When they say negative, of course, we are referring to how the line thunderstorm will affect us in a bad way. This is negative, in a bad way. And they're saying on the environment, so we need to take note of this, on the environment of the eastern half of South Africa. Okay, let us try to look at those negative impacts of the line thunderstorm on the eastern half of South Africa. 1.4.5. Negative impacts would say results into soil erosion, which affects the environment. Cause floods, destroying vegetation, as well. Results into leaching of the soil, where nutrients pushed further downwards, pushed further as well, disrupts the ecosystem destroys the natural habitats. Natural habitats. Could as well cause mudslides and landslides. So we are linking most of this to line thunderstorms because we know they are associated with heavy rainfalls. That's why we are saying, firstly, it will cause soil erosion because when there's a lot of rainfall, there will be too much surface runoff, which could result into the washing away of the topsoil and its fertility. It could as well cause floods that could destroy the vegetation, including trees, crops, etc. Results into leaching of the soil where nutrients are pushed further downwards, meaning that the topsoil will be barren or won't have enough fertility to support the growth of crops because the fertility has been pushed further downwards due to a lot of infiltration being caused by too much rainfall. The ecosystem as well will be disrupted due to some organism or being destroyed or being killed, and as well the natural habitats destroyed. It could result into mudslides and landslides because we know whenever there is too much rainfall, the soil at times it get loosened and to start to slide downwards, which would be as well a danger. All right, so that is for question 1.4.5. All right, so now we're going to question number 2, which is geomorphology. So question 2, geomorphology, they say, choose a term from column B that matches the illustration in column A. Write only the letter X or Y next to the question numbers as shown in brackets 2.1.1 to 2.1.5 in the answer book. For example, 2.1.6, which is X. All right. So we're just choosing a term from column B that matches the illustration in column A to make everything correct or true. Now 2.1.1, they say cross profile of a river, sorry, it's X indicates a cross profile of a river and Y longitudinal profile of a river. So for this case, our answer will be X, which is a cross profile, because if we check, we are looking, they're showing us the shape, because the cross profile, this profile shows the shape of a river at different stages. Like in the upper course, where it's gonna be deep, narrow, the middle course to be a bit wider, and in the lower course to be a bit gradual. You see, so you can see these are different shapes of the river, but at different stages or at different courses. So if you look at this one here, you can as well see it's showing us a shape. You see, that's why we say that our answer for 2.1.1 is a cross profile, because the cross profile shows different shapes. All right, 2.1.2, there is X is a waterfall and Y is rapid. And as you can see, this isn't a waterfall because for a waterfall, water has to be flowing over a resistant rock or where there is a cliff. So this is a cliff, for example, and this could be our water flowing over this point, forming waterfalls. But if we look in this diagram, you can see these are rocks along the river channel. These are rocks, and where we have rocks along the river channel, they'll end up forming or creating rapids, or what we call mean waterfalls. So that is why for 2.1.2, most of those will be rapids. Okay. Then 2.1.3, they say X turbulent flow, Y is laminar flow. So for this case, our answer will be laminar flow, which is Y. The laminar flow. Okay, laminar flow. Why we say laminar? Because in a laminar flow, the river course is smooth, see, without any base levels of erosion. This is an example of a laminar flow profile. If I show you the turbulent, it will be something like this. You see, where the river profile is not smooth. So if we check here, you can see that this river, it is smooth throughout. There are no changing of levels. See, unlike the turbulent, they're changing of levels. See, therefore we say it will be as this one here, which is a laminar flow. Okay, so this is laminar, got a smooth concave profile, got a smooth profile. You can see this one has got a rough profile. That's why our answer will be laminar, which is Y. At 2.1.4, X is braided stream and Y is a delta. But what are these? So our answer is going to be the braided streams, because I can see sandy islands, the sandy islands being deposited inside the river channel, but then there are different streams that have developed. You see, this gray or the dark one shows streams of water that have developed, and this is typical of braided streams. So that's why we shall say that will be a braid. But don't forget, they both form due to the same process of deposition. However, a delta will be found at the river mouth. But as you see here, this is still somewhere in the lower course, but not already at the mouth. So the answer will be a braided stream. 2.15, graded river profile or ungraded river profile. So this is going to be ungraded river profile. Because with ungraded, we see the profile is not smooth. It's like this. It's not smooth, which is a typical of ungraded profile. If it was graded, it was supposed to have a smooth profile throughout. You see? So this profile is smooth, which we refer to as graded. In this profile, it is rough, which is typical of ungraded. As you can see here, water is coming like this, then here it rises again, then here there is that, then there is that. So it means that in the river course, there are so many rapids that have developed. So that will be typical of a ungraded river profile. All right, let's proceed to question 2.2, which says, refer to the figure below illustrating fluvial landforms of a river. Match description with A to E on the diagram. Write down only the question numbers 2.2.1 to 2.2.5 and the answer in your answer book. All right. So this is our figure below. As you can see, they are referred to this point as A. We have point B there. We have point C. We have sorry, this is point C here. No, this is point C. This is point D. This is point E. This is the river, the levee there, the channel, and this is the mouth, and their estuary here. Okay. So the instructions say refer to the figure below illustrating fluvial landforms. So what are fluvial landforms for this case? Fluvial landforms. As well refer to features developed due to reverse activities. It simply refers that when a river is flowing, it is carrying out activity or it is doing work. So for this case, those activities includes erosion, transportation, and deposition. So if it does so, it will end up developing different features along its course. And these features are what we refer to as fluvial landforms. Okay. So 2.2.1, they said the origin of the river. I think all of us we refer to that as point A or the source. So you could say point A or the source, because we know the source is the starting point of the river, and always the source is found in the higher areas. So you can see that this side, the gradient is steep or it is high. You see, side is high, this side is low, meaning river is flowing from a higher point to going all the way to the lower point. Okay. The number 2.2.2, cut off meander loop filled with water. So for this case, that would be point D, or you can also refer to it as the Oxbow Lake. It is referring to a cut-off meander loop. A loop is that bending part. As you could see it, if I try to zoom in for you, you can see this is our loop here. This is the loop. See, which used to be part of this meander or part of this river, but now it was cut off during the process of erosion and deposition, therefore forming a meander loop or forming a cut-off meander, which as well we refer to as the Oxbow Lake. All right. Then we go to question 2.2.3, a distinct curve or loop in the course of a meander channel. A curve in the course of a meander channel. All of us know that when we talk about a curve, they find something like this. This is a curve. This is another curve. So you can see it is curving there, it is curving here. So what is this curving called? All of us know that the curve is a meander. See? That's why if we are to define a meander, we could say these are bends or curves in a river channel. Okay. Then 2.2.4, the branch of the main river, So for this case, it could be point E, or it could be point E. That's a branch, see, which is a tributary. So point E, and then we say a tributary. Then number 5, so 2.2.5, the positional feature close to the mouth of the river. The positional feature close to the mouth of the river. So that is going to be, this is the mouth here. Try to make it more clearer. Right. So this is the river mouth. The river mouth here. Now, when they say the positional feature close to the mouth, so they are referring to this, which is point C. So that could be point C, or could as well say a delta. Sorry. Okay. Call it a delta, or distributaries, because all these are found close to the river mouth. Delta, tributaries, or the estuary. So all those are found close to the mouth of the river. Let's proceed to question. Let's say, try to reduce the font, question 2.3, which says, refer to the figure below, which shows a river capture. So we are seeing the other side showing us before river capture, and this other side after river capture. So they said define the term river capture. The concept is capture. Okay, river capture. So define the term river capture. So I was saying the concept is capture. So you could say energetic river stills the weaker river. So we are looking at this concept, which is still. You see, which is still. Or we as well say when energetic river stills headwaters of a weak river. So the concept here is this word to still. Some learners, they usually repeat the concept where they say river capture when a river captures another river. So we want to understand the concept of capture. That is why we are using the word to still. Or we as well say so that energetic river robs. Energetic river robs the weak river. So the concept is as well to rob, you see? All right, so 2.3.2, they say Identify the drainage basin feature labeled C. This is a feature C here. As you can see, a feature C, which is going to be what? You can see we have this other stream here, we have this other stream. So it means that feature C is somehow trying to separate this stream from this other stream. So, which means that feature C is a watershed. A watershed, which is separating the other river from another river. Then 2.3.3, they say identify the type of erosion taking place at B. Identify the type of erosion taking place at B. So this is point B here. So you can see that this river was able to erode through, because we said that there was a watershed here. This used to be a watershed. You see, it was like this. It used to be like this before. All right. But because this river was more stronger, it was able now to erode through this watershed, and it was able now to steal the other river, right? That is why the type of erosion taking place here, we refer to it as the headward erosion. Headward erosion, where a river erodes backwards. So the type of erosion at B, that is the headward erosion. Headward erosion. All right. Now, 2.3.4, name the features of the river capture marked A, D, and E. Let's look at feature A first. So feature A, as you can see here, feature A, there's nothing here. And all of us know that one, we call it a wind gap, or a dry pad. So if I can write it again here, then we say feature A is a wind gap in bracket a dry pen. Yeah. So feature A, like we said, wind gap a dry pen. Then we go to feature D. Feature D. Feature D. This is feature D. This other side. This other side before the capture, which is the capture stream. Why we say the capture stream? Because it was this river which was able to erode through the watershed. Then it was able to intercept this other stream. That's why we refer to it as the capture stream. Remember, a capture is the same as the energetic stream. So I could say feature D is our capture stream, can be called a capture stream, can be called a pirate stream, can be also called a victor stream. This is the energetic stream which was able to steal energetic. Let me just make the spelling very correct. Energetic stream. Energetic stream. That is feature D. If you check feature E, this is our feature E here. Remember, feature E is the one which lost its source. Because remember, it used to flow like this. It used to flow like this all the way. But now, that no longer happens. Why? Because now, this river is now on its own, you see? That's why here we said there is a wind gap, dry. So this area is dry completely. There's no water, meaning that feature E no longer has any water source. That's why we call it a misfit stream or a beheaded stream. So we could write feature E here. Could call it a misfit or, sorry, make it more clear. Misfit in the bracket. We'll call it a beheaded stream. Okay. 235, they said, discuss one climatological reasons why river capture has taken place. Climatology. So we're dealing with rainfall, because we know wind, not really, temperature, not really. So it means it could be rainfall, which will contribute to river capture, which is part of climatology. 236, discuss the impact of river capture on the flow characteristics of the stream labeled E. Discuss the impact. What is going to happen to river E after capture? Let's check which one is the river E. Yes, this is our river E, and we say that river E is a misfit stream. All right. So we could say one of the impact, it will have low volume of water, its erosion, will decrease. We could say that there will be more deposition. Because the river are no longer able to transport materials. The velocity or the speed will reduce. Velocity or speed will reduce. Okay. That wanted 3, but given 4. Okay, so we proceed to question 2.4, which says, study the figure below showing river rejuvenation. And they're saying figure A shows before rejuvenation, and figure B after rejuvenation. All right. Now they're saying define the term river rejuvenation, and we could say a river gains energy. Erode vertically again. So this means that before the river was more energetic, then it lost its energy, right? However, due to other factors, this river, it's like it was being reborn again. So it was able to regain its energy. And whenever the river gains energy, it makes it able to start eroding its valley or its channel vertically. Then we say it has been rejuvenated. All right, so they say, name the fluvial landforms A and B. Don't forget, whenever you see the word fluvial landform, like we spoke earlier, these are features or landforms that are developed by the river because of its activities or processes such as erosion, deposition, and transportation. Therefore, we say because of the various activities, so different features are going to develop. So they are asking, what is feature fluvial landform A and B? So we could say that A, this is A, you can say that this is a flat area. Which is a flat area. So meaning, you can see that feature at A, the land is flat. The land is flat, and remember, this is the river channel here, right? This is the river channel. So if we see a flat land, which is close to the river channel, so we refer to this area as a floodplain. So mean that feature A is a floodplain. So what is a floodplain? We define it as a level area, level or flat area next to the river. Level or flat area next to the river, right? That is a floodplain. Then feature B, if you can look at feature B very carefully here, you see somehow there is a rise in this part here. You see, there's a kind of rising somewhere here. You see, and it is too close to the river. But somewhere here, you can see this other side, it is flat, which is a floodplain. But here, there is a rise at this particular point. And that rise is what referred to as a levee or a natural levee. That is a natural levee. So we say that feature D, check again. Feature A. Feature A, we said feature A is a floodplain. Floodplain, flood, not flat. Floodplain. And the feature B is a natural levee. This is going to be a natural levee. What is a levee? A levee refers to a raised riverbank. Let me try to explain it here. A levee refers to a raised riverbank. It is a natural levee. That's why I said that if you check here, that this side there is kind of materials that are piling up, and if materials pile up here, so that the riverbank is going to rise up, creating a natural levee. Okay, so 2.4.3 feature D. Feature D in figure B indicates rejuvenation. Feature D in figure B. This is our feature D here. But one thing you can see if you check something like that, you see. So when you see such, it looks like a step, right? It's like someone is coming, then it climbs, you see. So when you see such features, it looks like a step. And we refer to this as a river terrace. River terrace, which is develops during river rejuvenation. So I could say that feature D is a river terrace. What is a river terrace? It is a step-like feature. step-like feature. Okay. Now 2.4.4, give two reasons for rejuvenation. What makes a river to regain its strength or its power to start eroding? So we could talk about rainfall. We could as well say more water. Talk about drop in sea level. Drop in sea level. Rise in gradient. Rise in gradient. We could as well say isostatic uplift. Isostatic uplift of the land. So all these could result into a river being rejuvenated or to regain its energy. Okay, 2.4.5, they say, explain how rejuvenation will affect the flow of the river downstream. So how the river rejuvenation affect the river flow downwards? We can say the river will become more stronger, to erode downstream. So the river erosive capacity will increase. So the river developing points, rapids, rapids inside the meanders, downstream. Next, so develop sorry for that. Develop turbulent flow. So on this question, we're looking at what will happen to the river downstream after it being rejuvenated. So we say it becomes more stronger to be able to erode downwards, meaning after regaining energy, it will be flowing so fast, you see. So it will start now eroding the downstream. Its erosive capacity will increase to be eroding more than before. The river will develop neck points, rapids inside the meanders downstream. Remember, all these, they develop vertically due to erosion. Then also turbulent flow will develop in the lower course. As well as say that the velocity of the river will increase, river's velocity increase, river's velocity increases. Okay, so that is for question 2.4.5. So we are done with geomorphology. Now we are moving towards settlements. settlements. Okay. Question 3 talks about settlement geography, which says various options are provided as possible answers to the following questions. Choose the answer and write only the letter A to D next to the question numbers. 3.1.1, they say the dash is the actual place or piece of land on which a settlement is built. I think, or we argue that would be a site, because the site refers to the exact area where a settlement is built. 312, a dash settlement is where water is the determining factor when choosing a site, as it is located in a dry area, e.g., spring or oasis. So that would be it would be a wet point settlement. But when we say a wet point settlement, this is where water is not a risk. Unlike a dry point settlement, with a dry point settlement, they are situated far from a water source because water is seen as a threat. But when we say a wet point, that area water is scarce. Therefore, people usually locate close to the water sources. 313. The sketch below refers to that would be B, which is a linear, settlement, because you can see it is in the form of a line. You see, and these are the settlements. So that's called that. So we do refer to that as a linear settlement. Then 3.1.4, the disadvantage of the row settlement pattern below. I think you can agree that this is going to be a dispersed pattern because settlements are situated far from each other. You can look at the distance. They are far from each other. See. So this pattern is referred to as a dispersed pattern. Now, if you live in such a settlement, well, what would be the disadvantages? Let's check. One, the farmers cannot rely on the community for any help, which is true. So if you're in such a settlement, you cannot rely for a neighbor who's in hundreds of kilometers away from you. It requires a large amount of capital to maintain the farming, which is also correct because now you are living on a big farm by yourself. It's a big farm for this person, but you need a lot of capital to maintain all of this huge farm. You see, that becomes a disadvantage because it means you need to spend a lot of money. Okay, what is surrounding this settlement? Could look at the transport, which is correct. The aspect, that could be the angle at which the sun is rays strike the settlement. So let's check on the options. So option 1 and option 2 are correct, which means that A is the correct answer for our situation. Okay. Let's proceed to 3.2, which says choose a description in column B that matches a concept in column A. Write only the letter next to the question number. For example, 3.2.1 to 3.2.5 in the answer book as 3.2.6, then you write the letter there. All right. So 3.2.1, they say level of urbanization. And X is saying the percentage of the number of people living in urban areas. Option Y, increase in number of people living in urban areas. I think our correct answer is going to be X, got the percentage, because this one, the increase in number, does not just refer to urbanization, this one. Refer to urbanization. Yet the level, we're looking at the percentage. We want to give the number of people in urban areas, but living in urban areas, but in percentage, which is the same as the level of urbanization. 3.2.2, urban sprawl. X, the physical expansion of an urban area, and Y, the formless expansion of an urban area. So you're going to take Y because the physical expansion here will refer to as, this is as same as urban expansion because it looks at the physical expansion. However, urban sprawl, this one we're looking at the formless expansion. It means in most cases, this is not planned. It is not planned, or could as well refer to it as uncontrolled. Uncontrolled or not planned expansion of an urban area. You can find an informal settlement in a night and people have invaded an area. So we refer to that as urban sprawl. 3.2.3, central places. Option X talks about, refers to the physical expansion of an urban area, and option Y, this town developed due to one main function. So Y will be the correct answer. Why not X? Because X as well, it is referring to urban expansion. Yet the central police, these are towns that develop due to one main function, meaning, let us say, for example, here, this could be our central police town. Maybe it is an educational town, meaning there are a lot of schools, universities, colleges. So meaning it will be offering services to all these surrounding places. All these areas will be converging to get the education from this central place town, because the main function or the dominant function is education. That's why we're going to refer to it as a central place, meaning it is serving the surrounding areas with education. All right. Then 3.2.4, 3.2.4, so 346, discuss the impacts that the urban issue referred to will have on people in urban areas. So you could say results into increase in crime. Crime rates. People will not feel safe in such areas. The place not look pleasant. To the tourists. It will scare away business investors. Okay, our business investors. So results in true. Sure. Such as drug abuse, uh, the poor service delivery as well in such areas. Just can mention about let's not look present about that. Because of the rivalry, a lot of vandalism, returning in the area. All right. So that brings us to the end of a theory. So now our next will be geographical skills and techniques. So this one we're going to use a map for us to understand more of these questions. All right. Let me try to get our map as well. All right, this is gonna be our map here. So I'll be zooming in and out so that you can see clearly. Okay. So section B, question 4, geographical skills and techniques. This is the map of Southern Africa. Sorry, yes. Including countries like Lesotho, Swaziland, and South Africa. So this is Agravis. They're giving us the coordinates: 28 degrees, 35 seconds south, 20 degrees, 20. So it was 35 minutes, 20 minutes east. They say Agravis is a small town in the Northern Cape province of South Africa, situated on the south bank of the Orange River, about 100 kilometers downstream from Uppington. It is located on R359 Road, just outside the Agravis Falls National Park, which contains the Agravis Falls for which the town is named. The following terms with Afrikaans translations are shown on the topographic and author photo maps. Okay, they say the feature found at grid location 28 degrees 36 minutes 13 seconds south, 20 degrees 20 minutes 27 seconds east is what? Let's first locate the 28 degrees on our map. They say 28 degrees. So this is our 28 degrees. Sun here. Let me see. Sorry about that. Okay. So let's see. Can use a different color. Okay. Okay. So you can see this is our 28 degrees. Let's try to zoom in. So you can see try to remove this. Because the question is asking, the future found at a good location, 28 degrees, 36 minutes, 13 seconds. So we have our 28 degrees here. Okay. Then it say 28 degrees, 36 minutes. Well, this is 35 50 minutes. This will be our 36 minute here. And 13 seconds. 13 seconds, let's check. Because we know from here up to here, it is 60 seconds. So half of this will be 30 seconds. Then half of 30, it means somewhere here. Could be 15, 15. Then 13 could be somewhere here. Could be somewhere there. Could be our 13. All right. Then if we are to check on our question once again for the longitudes, it's saying 20 degrees, 20 minutes. Saying 20 degrees, 20 minutes, 20 degrees, 20 minutes. So these are the degrees for the longitudes, 20 degrees, 20 minutes. So this is our 20 minute here. So the seconds, there are 27 seconds. But check 27 seconds. Remember, we know that from here up to here, it is 60 seconds. So half of 60, it will be 30. So if this is if this is 30, it means 27 could be somewhere here. All right. So if you use a straight line to draw this longitude to intersect with our latitude here, excuse me. So sorry for the interruptions. However, we're looking at the way our group is situated in which province. We go back to the information that was given to us above, which says Agrab is situated in the Northern Cape province on the south bank of Orange River, about 100 kilometers downstream from Uppington. And there was some information there. So we said situated in the Northern Cape province downstream of Uppington, which is 1 and 4. We have option 1 and 4 here. Let's check again. Very sure. Northern Cape provinces situated on the south bank of the Orange River downstream from Uppington. We said Northern Cape. So do we have Northern Cape here? Yes, we have Northern Cape down, which is 2 and 4. 2 and 4, which is option number C. In 4 and 3, choose the likely rough cross section from 6 to 7 on the orthophoto map. Okay, 26 and 7. Let's go back to our map. We see need to use the orthophoto map. So our orthophoto map here. All right. All right. Go to our orthophoto map. There. Okay. I'll try to reduce on the size a little bit so that it could fit nicely. Okay. So the question says the cross section, choose the likely cross section from 6 to 7 on the orthophoto map, 6 to 7. Let's look for 6 to 7. Sorry, 6 to 7. Yes, this is 6 to 7 here, as you can see. Okay, so we have, there is a river here. We have the contour lines. So you know well that when the contour lines are far from each other, if you compare this and this, which shows a gentle gradient, then somewhere here is a little bit steep here because there's contour line here, and the contour line, this contour line. So this side is more gentle than this other side. All right, so if I'm to draw cross section, so I'm going to show, let's go to the rough page. Okay. So the other side was a bit gentle. We had our river in the middle there. Then this side was a bit steep. However, let's first go back to the question just to formalize once again. Cross section in 6 and 7. But one thing we need to check here is that when we see something here, there is a meander. See, the river is meandering here, which means there's a meander neck, there is a loop here. So this side you can see is a bit gentle, this side is a bit steep, which if I'm to show it here, a bit gentle, then a bit steep. See? So if we check on our options, you can see option A showed both sides being steep, which is not the case because steeper sides, as we are supposed to show contour lines being close to each other like that. See, which means option A is not correct. If we check option B, it is indicating the other side being too steep, the side being gentle. Let's check on the map once again. Let me try to erase this. Okay, you see on point 7, it's more gentle, right? It's more gentle, and this side is a bit more, because if you look at the contour lines are close to each other, which shows a bit steeper, and this side they are far, which is gentle. Now, coming back to option B, assuming this is our let's check on the map again, where is point 6 and 7. You can see point 7 is gentle, point 6 is steep. So this side is supposed to be 0.7, it's supposed to be 0.6. So 0.7 is supposed to be gentle, but on this case, 0.7 is more steeper. If we check on point C, sorry, diagram number C, diagram number C, you can see this is 0.7, this is 0.6, whereby this other side is a bit gentle, as you can see. Then here it is steep, which is more likely the same as here. So this side is gentle because contour lines are far from each other. Then this side, it is too close. See? Which shows the contour lines are close to each other. So which means that we're going to go with option C as our correct answer. Option C. All right. For question 4.1.4, they say determine the magnetic bearing from trigonometrical station 74, block A4 to spot height 652 in block C5. Show all calculations, marks will be awarded. They're saying magnetic bearing, and they're giving us the formula here, which equals to true bearing plus magnetic declination. But when you look at the question, they didn't ask us to find a current magnetic declination, which means we are going to use the declination on the map. All right. So if I find our declination, we need to check again on our topographic map. Scroll down. All right. If you try to zoom in, okay. It first identify the mean magnetic declination, which is 19 degrees, 24 minutes. That is our declination, which is, so we're going to say MD equals to 19 degrees and 24 minutes. Okay, 24 minutes. Then we need to find a true bearing as well. True bearing. They say determine the magnetic bearing from trigonometrical station 74 in block E4. Let's look for 74 in block E4. This is E1, E2, E3, E4. So this is our trig station here. We want us to look at E4 and as well spot height 652 in block C5. 652 in block C5 is for C. 652 in block C5. So this is our C5 here, right? So now we need to do the true. We need to find the true bearing. True bearing. Okay. So how do we do that? Go back to the question. Find determine the magnetic bearing from the trigonometrical station 74. From trig station 74. So it means we are going to draw our north-south line at trig station 74, north-south line. You use a ruler and you draw a straight line across 74. Then after that, you're going to join the 2 points with a straight line as well. Let me try to reduce on the, so you can see nicely. So thereafter, you're going to join the spot height. You use a straight line, spot height, and trig station, right? So it means you need to find a true bearing. This is our true north here. So you need to use a protractor. You place a protractor at the north-south line, then you read clockwise from the true north to the line that the line that is joining the spot height and the trig beacon. Since we don't have a protractor, just try to estimate. Let's say our true bearing from here to here. Let's say 23 degrees. Okay. That's why we've got 23 degrees. So we're going to come here and we say our true bearing is 23 degrees. Then what we do, we're going to add, and we say 19 degrees, 24 minutes, plus 23 degrees. So which will give us 24 minutes, 9, 10, 11, 12. It will be the same as 42 degrees, 24 minutes as our magnetic bearing. Remember, this one I'm just not accurate true bearing because I'm not using a protractor to get the accurate true bearing. Okay. 4.1.5, they said, to line 8 on the orthophoto map, the vertical interval of the line is 4 meters. Let's go back to the map. Look to line 8. Okay. This is our line 8 here. Our line 8 from here up to here. So they're saying they give us the vertical interval, which is, let's see, vertical interval of the line is 4 meters. It's 4 meters. 4 meters. Because now remember, if you look at the formula for gradient equals to vertical interval over horizontal equivalent. So the same as the difference in height. Difference in height. Okay. Horizontal equivalent is the distance. All right. So they have given us the vertical interval, which is 4 meters. So we're going to say we have our 4 meters. Let's do it here. Gradient equals vertical interval over horizontal equivalent. They give us this one, which is equals to 4 meters. So we need to find the horizontal equivalent, which is the distance. So meaning, if you go back to our map, so we need to measure in centimeters across through line 8. So let's say our centimeter, we're going to say, let's say 5.3 centimeters. So use a ruler to measure from here to this point. Okay. So let's say we got 5.3 centimeters. But remember, in a gradient, everything has to be in meters. So we're going to say 4 meters over 5.3 centimeters. So we need to convert the distance to meters. That's why we use the scale of 100, since we are using the orthophoto map. Now, when you go to, if you use your calculator, and you say 5.3 times 100, do it for me quickly there on your calculators. What are you getting? 5.3 times 100. You're going to get 530. So to give us 530, give us 530 meters. All right. So it means now we have 4 meters over 530 meters. So if everything in meter, then you can now start to, we're going to see the figure on top divides by itself, 4 meters. What you do on top, as well do it at the bottom, divide by 5, divide by 4 meters. So you say 4 divided by 4, get 1. Remember, the answer for gradient must be in ratio. Must be in ratio. Then you say 530 divided by 4. What you get, you're getting 132. 32, 5 as our answer for gradient. But remember, for the distance, we just estimated since didn't have a physical map on me to do the actual measurements. Okay, but those are the steps. Question B. Okay, here they said question A. What is the horizontal equivalent? Remember we said we estimated and we gave 5.3 centimeters, right? Which is the same as bracket 130 meters after the conversion. Then for this one, number B, our answer would be 12132,5. Okay. Then 4.2, the general direction in the area covered by block before on the topographic map. All right. So let's check that topographic map for this case. They said before. This is B1, B1, this is B1, B2, B3, and B4. So how are we going to tell the wind direction here? We're going to look at the rows of trees. This is a farm here. There's a farm, and we all know the importance of the rows of trees along the farm is to block the act as wind breakers. It means they reduce down the strength of the winds. So for this case, it means the winds were coming in this from this direction. Why? Because that's where the trees are being planted in that direction to ensure that the crops here are safe from the incoming winds. So that these winds are coming from, if you use the compass, put our compass somewhere here in block B, whatever. So these winds are coming from the northwest. All right. By the mere fact that we are looking at the roar of the rows of trees in this area. That's why we're saying that we come from the north. This is our G. So there are islands there, and islands there. To that show that there is a river flowing over that particular area. Therefore, we're going to say that they're saying, so we take out option C, and because C, it is referring to the pattern, not the type. So we only have two types here. We have a hamlet and we have a town. And since we saw that at this point, you can see the farms even have names. It could be commercial farms, but there are these small dwellings or settlements, which means this is a hamlet. So we're going to take option A as our correct answer. 4.2.4, refer to the fluvial landform found between block B1 and C3 on the orthophoto map. The fluvial landform, right? Fluvial landform found between blocks B1 and C3 on the orthophoto map. Let's go back to our orthophoto map. Okay. This is our block C1, C2, C3. The question says again, the fluvial landform found between blocks B1 and C3. This is B1 here, B1, and C3. Let's check the question again. It says the fluvial landform found between block B1 and C3 on the orthophoto map. Okay. Okay. B1 and C3. This is B1 here. This is 3 here. What can you notice here? You can look at this part. You can see the contour lines, how close they are. This other side, and as well somewhere here, contour lines are too congested. You see? Now, whenever contour lines are too congested, it's going to indicate a steeper gradient. Okay? Steeper gradient, steeper gradient. It means in between, it's like there is, because this dark part here, the dark part, it does indicate or does show us the flow of water, which could be a river. So meaning, when you look at the steepness, side is steep, and there is a river flowing through. So we refer to that as a gorge. So that feature is going to be a gorge. Now describe the slopes of this landform, like we've mentioned. The slopes are steep, and they tend to describe, like we need to give a reason why are they steep. But for the map, then we say because contour lines are close to each other. Close to each other. So this shows that the slopes are steep. If you check again, if you go and check again, you can see, look at how these contour lines are too close. See, so they indicate that the gradient is steep. All right. So will Agrabah's waterfall at 9 retreat in the southeasterly or northwesterly? Give a reason for your answer. Let's go check again. Okay, try to remove this. Okay. Okay, so this is our waterfall. This is our waterfall at this point here. So they say, let's go back to check the question again. Will the waterfall at 9 retreat in southeasterly or westerly direction? I'm going to say it will retreat in southeasterly. Southeasterly, give a reason. So we're going to talk about headward erosion, because we know because of headward erosion, this results into the waterfall retreat in the southeasterly direction. I believe we spoke about headward erosion when we are looking at geomorphology under river capture. All right, let's go to question 4.2.5. They say refer the settlement at H on the topographic map. Let's check settlement H on topographic map here. Settlement H. Okay, this is our settlement H here. Okay. I can, so the question, let's check the question. The first question says, identify the pattern of the settlement at H. As we know, we have two major patterns. We have the clustered and dispersed. What can you see here? Because the whole of this is settlement H. Look at the dwellings, or look at the settlements. They are close to each other. You see, which means that our pattern for this case will be nucleated pattern. Created they're saying that what is the shape of this settlement? Let's check back on the map again. The shape of this settlement. I think we need to be very careful here. We need to identify the physical feature along this area. So I think you can see we have these roads here. These roads which are crossing through each other. They are roads, right? So certainly that develop where roads are cross through each other. So we're going to refer to this as a crossroad. So we could refer to it as a crossroad, because roads are crossing through each other. So a crossroad shape. Then they say, explain one factor that influenced the pattern of this settlement. The pattern of this settlement. Talk about the transport because of the roads. That's why the shapes like that. They put transport. Because roads cross through each other. Roads cross through each other. Okay, let's check if there could be another factor about transport. Yeah, for now, let us go with transport. In 4.3, they say the geographical information system, and they say that the data layers found in block F4 on the orthophoto map are what? Data layers found in block F4 on the orthophoto map. Let's go to the orthophoto map. Okay, a bit up. Block F4. Okay, so this is F4 here, data layers. So one, I think there is a river. Before I do that, let's first go to check where this orthophoto map was taken. It was taken from this area here. Okay. So meaning we have different layers of information in block F4. Okay. Data layers found in block F4 on the orthophoto map. Okay. Talk about drainage. Those are rivers. Let's consider that. Because like you mentioned, there is this is a river which forms part of the drainage. Another factor, there is infrastructure as well, GIS, which includes also map work skills and techniques. All right, so those are the instructions as usual. I think I'll leave that for now. However,